The relationship between weight, mass, and apparent weight. Mass, a quantity that describes an object's inertia, its tendency to resist being accelerated. Loosely speaking, it also describes the amount of matter in an object. Mass, measured in kilograms, is an intrinsic property of an object. It has the same value wherever the object may be and whatever forces might be acting on it.
Weight. It is a force, but specifically it is a gravitational force exerted on an object by a planet. Weight is a vector, not a scalar, and the vector's direction is always straight down. Weight is measured in newtons. Mass and weight are not the same thing, but they are related. This is the weight variable, this is the mass variable, and this is the free fall acceleration. Apparent weight. Your sensation of weight, how heavy you feel, is due to contact forces supporting you. Apparent weight can be defined in terms of the force you feel. And this is the equation, so apparent weight is equal to the magnitude of supporting contact forces. In an elevator, the only forces acting on a person are the upward normal force of the floor and the downward weight force. When the elevator starts at the bottom and is accelerating up, the normal force is greater than the weight force. The person feels heavier than normal, and the net force is pointing upwards. In between, there is no acceleration, and then when the elevator comes to a stop at the top, the normal force is smaller than the weight force, and the person feels lighter than normal. The net force is pointing downwards. When the elevator starts at the top and is accelerating down, the normal force is smaller than the weight force. The person feels lighter than normal. In between, there is no acceleration again, and when the elevator comes to a stop at the bottom and the acceleration vector points up, the normal force will be greater than the weight force, and the person will feel heavier than normal. At the bottom, when the elevator accelerates upwards, the net force points down and the number on the scale increases. When the elevator reaches the top and comes to a stop, the acceleration points down, the net force also points down, and the number on the scale decreases. When the elevator starts at the top and then begins to accelerate downward, the net force also points down and the number on the scale decreases. When the elevator reaches the bottom and comes to a stop, the acceleration points up and the net force also points up, so the number on the scale increases.